What if I told you the difference between a perfect CNC part and a completely ruined one often comes down to a tool smaller than your finger? Not the machine. Not the software. Not even the design. Just the wrong end mill choice. No warning. No second chance. Just broken tools, poor surface finish, and wasted material. So here's the real question. How do professionals always pick the right end mill on the first try? Let's break it down simply. Part 1. What is an end mill? Simple understanding. An end mill is the cutting tool that actually shapes your material. Think of it like this. If CNC is the brain, then the end mill is the hand doing the work. Different shapes, sizes, coatings, and geometries. Each one designed for a specific job. But here's where most beginners go wrong. They think any tool can cut anything. That's exactly how you destroy parts. Left pointing magnifying glass part 2. Why tool selection matters. Choosing the wrong end mill can cause crossmark rough surface finish, crossmark tool breakage, crossmark excess heat, crossmark poor accuracy, crossmark increased machining time. But choosing the right one. White heavy check mark smooth finish. White heavy check mark faster cuts. White heavy check mark longer tool life. White heavy check mark perfect precision. So now the real curiosity builds. What makes one end mill different from another? Gear Part 3. The 4 key factors. Simple breakdown. 1. Material you are cutting. This is the first decision. Aluminum needs sharp, high-speed tools. Steel needs strong, heat-resistant tools. Plastic needs low heat, clean cutting. White right pointing backhand index rule. Material decides the tool type. 2. Number of flutes. Flutes is equal to cutting edges. 2 flutes best for aluminum, better chip removal. 3 flutes balanced performance. 4 plus flutes best for steel, stronger, smoother finish. White right pointing backhand index rule. More flutes is equal to better finish, less space for chips. 3. Coating. Coatings protect the tool and improve performance. Gold, tin, general purpose. Black, TiAlN, high heat resistance. Uncoated best for aluminum. White right pointing backhand index rule. Coating is equal to longer life plus better cutting. 4. Tool geometry. This is the shape of the tool. Flat end mill sharp edges, basic cutting. Ball nose smooth curves, 3D shapes. Chamfer tool edges and finishing. White right pointing backhand index rule. Shape defines the result. Part 4. Common mistakes, pain points. Let's be real, most people fail here. Using 4 flute on aluminum chips get stuck. Using wrong coating tool overheats. Ignoring feed and speed tool snaps. Choosing cheap tools costly mistakes. And the worst one. Guessing instead of understanding. Rocket Part 5. Simple Pro Method, step by step. Here's how professionals do it. Identify material. Choose flute count. Select coating. Match geometry to design. Set correct speed and feed. That's it. No confusion. No guessing. Just controlled precision. Electric light bulb Part 6. Real insight, curiosity payoff. Here's something most people don't realize. Even the best CNC machine can produce terrible parts if the tool is wrong. But even an average machine with the right end mill can produce perfect results. That's the hidden truth of CNC machining. Raised hand, wait till the end. This might change how you see CNC forever. Warning sign Part 7. Common mistakes, where most fail. Let's be honest, this is where things go wrong for most people. You pick a 4-flute end mill for aluminum, looks fine at first, but then chips start packing inside the flutes. Heat builds up. Finish gets rough. And suddenly your tool is ruined. Or maybe you choose the wrong coating. Instead of reducing heat, it traps it. Your tool wears out faster than expected. Then comes the biggest silent killer. Ignoring feed and speed. Too fast. Tool snaps. Too slow. Tool burns. Either way, you lose. And let's not forget this, buying cheap tools to save money. Sounds smart until one bad cut destroys your entire workpiece. But the worst mistake. Why try pointing backhand index guessing instead of understanding? That one mistake costs more than all the others combined. Rocket Part 8 Simple Pro Method. How experts do it. Now here's the difference, professionals don't guess. They follow a system. Step 1. Identify the material. Aluminum, steel, titanium, each behaves differently. Step 2. Choose the flute count. Fewer flutes for better chip evacuation. More flutes for smoother finishing. Step 3. Select the right coating. Each coating has a purpose: heat resistance, wear protection, or friction control. Step 4. Match geometry to your design. Sharp edges. Deep cuts. Fine details. Your tool shape must match your goal. Step 5. Set the correct speed and feed. This is where precision comes alive. Balanced properly, everything runs smooth. And that's it. No overthinking. No confusion. Just a clean, repeatable process. Electric light bulb part 9, Real Insight, the Hidden Truth. Here's something most people don't realize. You can have the most advanced CNC machine in the world, perfect calibration, high-end setup, and still end up with terrible parts. Why? Because the tool is wrong. But flip that around, even a basic CNC machine, nothing fancy, can produce incredible results. Why try pointing backhand index if the right end mill is used? That's the hidden truth of CNC machining. It's not just about the machine. It's about the decisions behind it. Master the tool and you control the outcome. Ignore it and even the best CNC mistake will fail. Why try pointing backhand index? What went wrong? Let's learn from each other and get better, one part at a time.